Today I'm going to talk about Hippocrates, who was the great mathematician who came after Pythagoras. Some called him the Loony mathematician, and I'll explain why today. What I've started with is a triangle ABC, and I've echoed the triangle by producing point E down here. He knew Pythagoras' theorem, which says the square on the hippopotamus, the square on the hypotenuse equals the sum of the squares on the other two sides. But he said, it's not just squares, it's any similar shape on the hypotenuse of a right angle triangle will equal the areas of the shapes on the other two sides. And I'm going to prove that with curves or loons. So what he did, he drew a circle like that, right? That curve plus that curve would equal the same curve there if I did that and put the curve there. But I'm going to put the curve the other side of that line here. And he said, so that curve bit there plus that curve bit there equals this curve bit here. But hang on, he said, this curve bit plus that equals the area of ABC. But if those two equal that, then those two plus that equals the area of the triangle ABC. So this curved bit, which he called a loon because it looks like a moon or a piece of moon, is exactly the same area of the triangle ABC. And what he discovered is the first figure bounded purely by curves that you could determine the exact area of, the first. And then he went absolutely loony because he did it again. So here we've got another one. This is an off-center right triangle, right? So we've got that. And now from here, I'm going to draw another one. That's it. And this one. Well, this loon equals that triangle, and this loon equals that triangle in area. And it's absolutely beautiful, isn't it? Now, if you really love loons, then you can really go mad by doing this. I'm going to draw quite a few of these now. And this time I'm going to draw a complete circle. Look at that. And a complete circle here. And now a complete circle here. Complete circle here.
These are all based on the centre points of the lines, aren't they?
Yes. And this one here, I think, is the last one. And now I've got a fascinating thing, because with this one here and this one here, can you see this loon here? This big sweeping loon here? Isn't that beautiful? Because what you've got is a lovely letter Q, a round bit with two tails. And what can I tell you about this lovely thing? The area of that equals that triangle. The area of that equals that triangle there. The area of that equals that triangle there, and the area of that equals that triangle there. So if you take the four areas of this Q, you get exactly the area of that triangle. And it's so beautiful, isn't it?
In terms of the area of this guy, or equivalently in terms of the area of this guy, because the last two guys have the same area. Well, if you remember the Pythagorean theorem, this length is the square root of 2